Mary Swarna Latha, working as assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the problems on the transformation of random variables. So already we have finished the transformation of a single random variable. You have seen two types of transformation. One is monotonic transformation, the other one is non-monotonic transformation. So monotonic transformation is nothing but single one-to-one mapping. So in the monotonic transformation, what having? You have seen monotonically increasing transformation and you have seen monotonically decreasing transformation. So for example, if you have a random variable x, you have transformed this random variable x into a new random variable y. Then if the density function of the random variable x is fx of x, then the density function of the transformed random variable for monotonic transformation, whether it is increasing or decreasing, has been given by fx of x into mod of dx by dy, where x is equals to t inverse of y. So this is a formula to calculate the density function of the transformed random variable y. If we know the density function of the original random variable x, then you can calculate the transformed random variable density function by using this formula. So this formula is used for what? Monotonically increasing or decreasing transformation. Now, the problem here they have given is, if x is a random variable with the probability density function of fx of x, then find the probability density function of y is equals to ax plus b. So now we have to see whether it is monotonic transformation or non-monotonic transformation. So what they are given here, they are given that x is a random variable. So what they are given here, x is a random variable, and they have given fx of x is the probability density function of the random variable x. Now what you have to calculate? You have to transform this random variable x into a new random variable y. Now what is y? Nothing but by performing operation on this random variable x, you got a new random variable y. Now what is the transformation or the operation you have performed on this random variable x to transform into a new random variable y? The operation is what? You have to multiply the random variable, the given random variable x with a constant a. So then what you are getting? You are getting a into x. After that, what you have to do? You have to add a constant. You have to add a constant b to the resultant signal. Therefore, what is the transformation here? You have to multiply the given random variable with a constant a and then add a constant b so that you got a new random variable y. Now, you have to observe what type of transformation. You have to observe that either it is monotonic or non-monotonic, you have to observe. So, how can you say that whether the given transformation is monotonic? Monotonic nothing but what I told here? One-to-one mapping. And what is non-monotonic? One-to-many mapping. So, what is non-monotonic? That is nothing but one-to-many mapping. So, what is my one-to-one mapping? Nothing but a single value in x corresponds to a single value in y. That is nothing but what? One-to-one mapping or monotonic transformation. Now, what is non-monotonic transformation? A multiple values in x. So, multiple values in x. Nothing but many values in x are corresponding to single value in y. That is called as what? Non-monotonic transformation. It means single value in y is corresponding to many values in x. That is called as what? Non-monotonic transformation. So what they are given here, y equals to ax plus b. So if x equals to plus 1, then what is y equals to a plus b. It means a single value in x is corresponding to single value in y. So that's why it is the type of transformation. Similarly, you can observe for any value of x. So for any value of x, y is giving a single value with corresponding to the, with respect to the given x value. That's why the type of transformation here it is called as what? Monotonic transformation. Therefore, the type of transformation they have given is what? Monotonic transformation. Now they have given y equals to ax plus b. That implies what is x equals to y minus b by a. So what is y equals to? Transformation of x. So by performing operation on x, you got y. Similarly, how do you get the random variable x? So by performing what? Inverse operation on y, then you are going to obtain the original random variable x. Then how can I write x equals to what? Inverse operation of the transformed random variable y. So that we'll get the new random variable, the original random variable x. Now, what is the density function of the transformed random variable you have given? Fy of y equals to what? Fx of x into mod of dx by dy at x equals to t inverse of y. So this is what? The density function of the transformed random variable. Now, you have to calculate what? Fx or dx by dy. So, you know x equals to y minus b by a. So, what is x value here? Y minus b by a. Now, differentiate both sides with respect to y. Then, what is dx by dy equals to 1 by a. Therefore, the density function of the transformed random variable has been given by fx of x into mod of dx by dy, nothing but what? 1 by a, where x equals to t inverse of y. So this is nothing but what? T inverse of y. Therefore here what is x equals to? Y minus b by a. So therefore Fy of y is equals to fx of x. What is x here? Y minus b by a into mod of 1 by a. So this is a density function of the transformed random variable. So we'll go for the next problem. If x is uniformly distributed in the interval minus pi by 2 comma pi by 2, find the probability density function of y is equals to tan x. So what they have given that? So they have given that x is what type of random variable? It is a uniform random variable. And which interval that has been distributed? It has been distributed over the interval minus pi by 2 comma pi by 2. So what is the density function of a uniform random variable which is distributed over the interval a comma b equals to, what is the formula? So 1 by b minus a when x is a to b and 0 otherwise. So similarly, if x is a uniform random variable, h has been distributed over the interval minus pi by 2 comma pi by 2. It means in place of a you have minus pi by 2 and in place of b you have what? Pi by 2. Then what is fx of x is equals to 1 by b minus a. So pi by 2 minus of minus pi by 2, that equals to what? That is nothing but 1 by pi. So for what values of x? When x is from minus pi by 2 to pi by 2 and 0 otherwise. For other values of x it is 0 when x is only from minus pi by 2 pi by 2. The density function of the uniform random variable distributed over the interval minus pi by 2 comma pi by 2 is given by what? 1 by pi. So what they have given that? We know the density function of the random variable x. After that what they have done? So find the probability density function of y equals to tan x. So what they have done? They have changed this random variable. So they have transformed this random variable x into what? Y. Therefore what is y equals to t of x. So what is a transformation or operation has been performed on this random variable x to get y? What you have to do? For the given random variable x, you have to calculate what? Tan of that value. So what you have to calculate? You have to calculate tan of the given x value. That is nothing but you are going to get a new random variable y. Now, you have to say whether it is monotonic or non-monotonic transformation. So, what they are given here? They are given y equals to what? Tan x. So, if you observe that for any value of x, if you take any value of x, y is giving only one value. Therefore, for all the values of x, y is giving only one value corresponding to the given x value. So, corresponding to the given x value. So, therefore, the type of transformation here is called as what? Monotonic transformation. So, the type of transformation is called as what? Monotonic transformation. Nothing but 1 to 1. One value in x is corresponding to a single value in y. That is called as what? Monotonic transformation. Now, for monotonic transformation, what is our density function of the transform random variable, which is given by what? Fi of y is equals to what? Fx of x into mod of dx by dy, where x equals to what? What is x equals to? Tan, so inverse transform of what? Y. This is the formula for what? Density function of the transform random variable. Now, what you have to calculate? You have to calculate dx by dy. So, what is y equals to? Tan of x. So, from this, what is x equals to? Tan inverse of y. Now, what is dx by dy? Nothing but what? Differentiation of what is x value here? X equals to what? T inverse of y. Therefore, what do you get here? D by T inverse of y. What is the differentiation of tan inverse y? Nothing but what? 1 by 1 plus y square. This is nothing but what? Dx by dy. Therefore, what is Fi of y equals to? Fx of x into mod of dx by dy. So, what is dx by dy? 1 by 1 plus y square. Where what is x equals to? What is x equals to here? Tan inverse of y. So, where x equals to what? Tan inverse of y. So, this is nothing but what? Here, what is x equals to tan inverse of y. Now, you calculate what? Dx by dy. Now, for what is fx of x value? This is equals to what? 1 by pi when x is from where to where? Minus pi by 2 to pi by 2. Now, you have to, for what value of y, it is fi of y equals to value. So, if x equals to minus pi by 2, then what is y equals to? Tan of minus pi by 2. Nothing but what? Minus infinity. Similarly, when x equals to pi by 2, what is the range of y? So, tan of pi by 2. What is tan of pi by 2 equals to infinity? Therefore, you can write down Fi of y equals to fx of x. What is fx of x? 1 by pi. So, what is fx of x here? 1 by pi into mod of 1 by 1 plus y square. For what value of x? When x is from, so for what value of y? When y is from minus infinity to infinity. So, this is a density function of what? The transformed random variable. So, like that, if they give the density function of the random variable x and the random variable x is transformed into new random variable y, then you have to say, you have to observe whether it is monotonic transformation or non-monotonic transformation. Then write the formula for the corresponding density function of the transformed random variable. Then write down the density function of the transformed random variable. Next problem is, if x is a continuous random variable, the probability density function fx of x. Find distribution function and the probability density PDF is nothing but probability density function. So, the probability density function of the random variable y is equals to ax square for a is greater than 0. So, what they have given that? They have given that x is a random variable. And moreover, what they have given that? The density function of the random variable x is nothing but what? fx of x. After that, what they have given that? Find the distribution function, density function of the random variable y is equals to a into x square. So what they are given here? Y equals to a into x square. Now, for example, if I take x equals to minus 1, what is the y value? A. If I take x equals to 1, y equals to a. It means many values in x are corresponding to a single value in y. Therefore, this type of transformation is called as what? Non-monotonic transformation. So, what type of transformation? So, many values in x are corresponding to single value in y. Therefore, the type of transformation is called as what? Non-monotonic transformation. So, for non-monotonic transformation, what is the formula for the density function? Fi of y is equals to sigma n fx of xn into mod of dxn by dy. So, this is what the density function of what? The non-monotonic transformation of the transformed random variable. Here, what you have to calculate? You have to calculate not only the density function, you have to calculate the distribution function also. So, therefore, what is the distribution function of random variable y? Fi of y is equals to what? How it is defined? That is defined as what? Probability of the random variable y takes up to the value of y. What is small y represents? A specific value in the random variable y. That is called as what? The distribution function of the random variable y. Now, P of, but they have given what is y equals to a into x square. Therefore, what is y equals to here? A into x square. So, less than equals to y. That implies P of x square is less than equals to y by a. That implies P of x is less than equals to plus or minus square root of what? Y by a. That is nothing but what? P of minus square root of y by a less than equals to x less than equals to y by a. Now, what do you call this as? The properties of, the properties of cumulative probability distribution function. From that, what can you say that? If x is from a to b, then the distribution function has been given by what? Fx of b minus fx of a. Similarly, here also fx of b. What is b here? Y by a minus fx of, so this is nothing but square root of y by a. So fx of root of y by a minus fx of root of y by a. So this is what the distribution function of the transformed random variable. And moreover, what you have to calculate? You have to calculate what? The probability density function of the random variable also. So you have to calculate what? The distribution function. Now you have to calculate what? The density function of the transformed random variable also. So you can find out in two ways. One is by using this formula, or else since already I have calculated the distribution function, you can calculate the density function as what? What is the relation between the density function and the distribution function? The differentiation of the distribution function gives what? The density function. So the differentiation of the distribution function gives what? The density function. So this is therefore Fi of y is equals to what? D by dy of, what is Fi of y here? Fx of square root of y by a. So fx of square root of y by a minus fx of minus square root of y by a. That equals to, so differentiate. Then what is the differentiation of the distribution function is what? The density function. So fx of square root of y by a into, what is the differentiation of square root of y by a? Nothing but what? 1 by square root of 2 into ay. Then minus, what is the differentiation of the distribution function is what? Density function. Distribution means capital F, density means small f. So fx of minus square root of minus y by a. And what is the differentiation of minus y by a with respect to y? So d by of minus of square root of y by a is equals to what? D minus of d by dy into 1 by root 2 into y. So how can I write square root of y as what? Y power 1 by 2. That equals to what? Minus d by, that equals to what? Minus 1 by root a is constant. And the differentiation of y power 1 by 2 is what? 1 by 2 into y power 1 by 2 minus 1. That equals to what? Minus 1 by 2 into square root of a by. So here what is the differentiation of minus square root of y by with respect to y? Then it what? Minus 1 by 2 into square root of a by. That equals to what? Fx of square root of y by a plus, so minus of minus is what? Plus. So plus fx of minus square root of y by a by, because this is common, you can take it as what? LCM here, therefore coming up to here 2 into square root of a by y. So this is nothing but what? The density function of the transform random variable. And you can calculate by using this formula also. What is f of y equals to sigma n fx of xn into mod of dxn by dy. So you can find out in this way, or else can find out the, if you know the distribution function, directly can calculate the density function. These are the two ways to calculate the distribution density function of the transform random variables. The next problem is, if x is a random variable with an exponential probability density function of the form fx of x equals to 1 by 3 e power minus x by 3 into u of x. So a new random variable is defined using the equation y is equals to 2x plus 1. Find fy of y. So what they are given here? They are given that x is a random variable. What type of random variable here? It is exponential random variable. And what is the density function of that exponential random variable? Equals to 1 by 3 into e power minus x by 3 into u of x. So how the, what is u of x? That is called as what? Unit step function. How the unit step function has been defined? So u of x equals to what? When 1 when x is equals to 0 and 0 when x less than 0. So if you plot here, you'll get like this. This is x and this is what? U of x. So when x is less than 0, it is 0. When x is equals to 0, it is what? 1. This is the definition of what? Unit step. Therefore, how can I write down this fx of x as what? 1 by 3 into e power minus x by 3. And for what values of x? When x is equals to 0. Because when x is equals to 0, it is 1. So 1 into something you are going to get 1 by 3 into e power minus x by 3. When x less than 0, it is 0. So 0 into something you are going to get 0. So therefore, it is 0 when x is less than 0. Next, what they are given that a new random variable y is defined is the equation y equals to 2x plus 1. So therefore, what is y? The new random variable y equals to 2x plus 1. Nothing but what? By performing the operation on the random variable x, you got a new random variable y. What is the operation you have performed here in the random variable x? Multiply the given random variable x. So multiply the given random variable x with what? 2. Then add a constant 1. Add a constant 1. Then we got a new random variable, the transform random variable y. Therefore, what is y equals to 2x plus 1. So by performing operation or the transformation in x, we got a new random variable y. Next, what you have to calculate? You have to calculate what? The probability density function of the transform random variable. So what type of transformation you have to calculate? So what is y equals to 2x plus 1? It means for a single value of x. If x equals to minus 1, what is y equals to minus 1? If x equals to plus 1, y equals to 3. It means a single value in x is corresponding to a single value in y. Therefore, the type of transformation here it is called as what? Monotonic transformation. So, monotonic transformation. Only one value in x corresponding to one value in y. So, for monotonic transformation, what is the density function of the transform random variable formula is what? We have seen fx of x into mod of dx by dy where x equals to what? T inverse of y. So they have given y equals to 2x plus 1. So from this, what is x equals to y? So bring this plus 1, you will get minus 1 and by 2. So nothing but what? Nothing but x equals to what? T inverse of y. In order to get y, what you have done? You have multiplied with 2 and then add with 1. In order to get x from this y, you have to first subtract minus 1 and then divide by 2. So that by performing the inverse operation on this y, you are getting the original random variable x. Then what is dx by dy? Differentiate and was with respect to y. So dx by dy equals what? Differentiation of y minus 1 by 2 with respect to y. What is the value you are going to get? 1 by 2. Therefore, what is fi of y is equals to fx of x. What is fx of x? They are given 1 by 3 into e power minus x by 3 when x is equals to 0. So here 1 by 3 into e power minus x by 3 into mod of dx by dy. What is mod of dx by dy? Got 1 by 2. And this is for what value of x it is? When x is equals to 0, it is 1 by 3 into e power minus x by 3. Now for what value of y you have to calculate. So y equals to what? 2x plus 1. So for what values of x it is? Fx of x equals 1 by 3 power minus x by 3 when x is equals to 0. So when x is equals to 0, what about the y value? Y equals to, y is nothing but greater than equals to 1. To substitute x equals to 0 here. So y equals to 1. It means for y is equals to 0, x greater than equals to 0 is corresponding to what? Y is greater than equals to 1. Therefore, what values of y here? Nothing but when y is greater than equals to 1. And when y is less than 1. So if y is less than 1, then what happened? So x is less than 0 is corresponding to what? Y is less than 1. So if for x is less than 0, for example, x equals to minus 1 you have taken. Then what is y value? Minus 2 plus nothing but y equals to minus 1. For negative values, what is that value? It is 0. Therefore, it is 0 when y is less than 0. Therefore, this is what the density function of the transform random variable. Or else you can write down like this also. Fi of y is equals to 1 by 3 into e power minus. And what is the value of y here? X equals to what? T inverse of y. Nothing but y minus 1 by 2. Therefore, y equals to what? What is x value? Y minus 1 by 2 by 3 into mod of 1 by 2 into u of x. So in place of x, write down here y minus 1 by 2. So you can write down like this also. So this is what the density function of the transformed random variable y. So like that, you can calculate the density and distribution function of the transformed random variable y. For that, you have to check whether it is monotonic transformation or non-monotonic transformation. Depending upon that, use the corresponding formula to calculate the density function of the transformed random variables. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.